So, we are going to study about hydraulic gradient line and total energy line. The definition of hydraulic gradient line is hydraulic gradient means P1 by rho g plus Z1. This means piezometric head. Hydraulic gradient of any point means right is P by rho g plus Z1 की value. Total energy line means total energy at a point P by rho g plus V square by 2g plus Z. Now hydraulic gradient represents piezometric head. Now going to the cases. This is the first case in which there is a flow in a pipe, and this is a viscous flow in a pipe. So first drawing the hydraulic gradient line. In hydraulic gradient line, as we go, pressure decreases, and pressure decreases linearly. dP by dx is equal to constant. So P by rho g plus Z1, as Z1 is constant everyone. So hydraulic gradient line is depending only on pressure, and as we go lengthwise, the pressure is decreasing. So hydraulic gradient and linearly decreases. So hydraulic gradient line decreases linearly. Now total energy at this point is P by rho g plus V1 square by 2g plus Z1. This point, and as we go here, the energy decreases due to head loss. And head loss is direct proportional to length because 32 mu average L upon rho g d square. Linear decreases in total energy. Second case, sudden expansion case. Sudden expansion case 1, 2, 3 point from hydraulic gradient line. From here to here, pressure decreases. Pressure decreases and H is constant everywhere, so hydraulic gradient line is only depending on pressure. From here to here, pressure is decreasing linearly. Now, due to sudden expansion, the velocity suddenly decreases. Suddenly decreases, this means pressure suddenly increases. So hydraulic gradient line sudden spike, and then again due to dP by dx is equal to constant, decreasement in pressure, dP by dx is equal to minus constant, so decrease in pressure. Total energy from here to here decreases due to head loss. Now from here to here there's other head loss, which is sudden expansion head loss. So total energy line again goes down suddenly, and then again decreases because there is again head loss. Now sudden contraction. The hydraulic gradient line is like this. Pressure decreases. From here velocity very increases, so pressure suddenly decreases, and then again pressure decreases. Total energy line. Due to friction it is decreasing. Now due to contraction there is other head loss which is involved. Contraction head loss. So it decreases and then again increases. The total energy line does not go up unless our external source is provided. It can go down, but it cannot go up. So it can be like this, total energy line, or it can be like this, but it cannot go up unless there is an external source. Suppose the external source is pump. From 1 to 2, we are drawing hydraulic gradient line. From 1 to 2, pressure decreases. So pump increases the pressure, so sudden increase in pressure, then again decreases. Total energy from 1 to 2, total energy is decreasing due to head loss, due to friction. Pump provides the energy, so total energy line goes up and then again decreases. Turbine is energy soaking from fluid, so hydraulic gradient 1 to 2 pressure decreases. Turbine also decreases the pressure, again decrease. Total energy from 1 to 2 is due to head loss, it is decreasing. From here sudden decrease due to turbine taking the power energy, then again this. Total energy line as well goes down in the direction of flow until or unless an external energy is supplied during the flow. Yes, power. Pump. Hydraulic gradient line may rise or fall in the direction of flow. Yes. The hydraulic gradient line will always be below the total energy line, and the vertical distance between the two represents the velocity kinetic velocity head. Yes. Suppose this is the case. So the difference between here will represent the velocity difference in velocity head between this. MCQ questions are all this. For a pipe of uniform diameter, okay, sudden rise or fall in TL occurs due to pump and turbine respectively. Yes. Total energy line for idealized Bernoulli flow is always horizontal. Yes, because there is no decrease in energy. But still, In ideal flow, मतलब Bernoulli flow, there still can be rise or fall in the hydraulic gradient line because P by rho g plus Z1. So P can decrease in the direction of flow even in Bernoulli due to velocity, due to changing diameter and velocity. Like suppose this is the case, sudden expansion or contraction. In sudden expansion contraction, at this point, here the velocity is decreasing suddenly, so pressure will increase even in Bernoulli flow. If velocity is constant, then P by rho g plus Z1 is constant, everyone, in Bernoulli equation. In a viscous equation, it is not, because there is a uh, dP by dx is equal to negative. At a sudden expansion of water pipe from diameter 0.24 to 0.48, the hydraulic gradient line rises by 10 mm. Find the discharge through pipe. So this is the case. It has said कि hydraulic gradient line का variation है 10 mm from 1 to 2. From 1 to 2 there is a so hydraulic gradient at 1 is P1 by rho g plus Z1, and at this is P2 by rho g plus Z2. And 10 mm difference means 10 by 1000. 10 mm, 10 by 1000 we have to write in meter. So this is the first equation. And now apply the Bernoulli equation between 1 and 2. 1 and 2, these are very adjacent points, and between 1 and 2 of course Bernoulli equation states ki what is the energy difference between the 2 points, this 1 and 2. If we are taking 1 here, 2 here, then P1 by rho g plus Z1 V1 square by 2 P1 by rho g plus V1 square by 2g plus Z1 plus all this head loss up to here. But as we are taking very adjacent points, so here P1 by rho g plus V1 square by 2g plus Z1 और इतने का हेड लॉस, इतना ही हेड लॉस. Here head loss is due to small length, this which is negligible, and due to sudden expansion. So this becomes, now the value we have just found, we find the value of V1, V2, and we find the value of Q. Now this is the same exact question just like previous one. Now don't solve this, head loss, don't put the values, just put them in equation. Use q1 is equal to a1 v1 means convert all things in v1 and diameter, and at last you will get d by d is equal to root 2, big D upon small d is equal to root 2 for maximum pressure, whose derivation goes like